Here we have a pre-calculus problem. Okay, let's go to the question. The inequality 1 negative x square over 2 less than or equal to sin x over x less than or equal to 1 holds when x is measured in radians and the absolute value of x less than 1. Find limit x tends to 0 sin x over x. Okay, so here we have a compound inequality. In this compound inequality, they are asked us to evaluate the function over here when x approaches 0. Okay, now let me write the given compound inequality as it is. It is 1 negative x square over 2 less than or equal to sin x over x less than or equal to 1. So we have to evaluate the value of this sin x over x when x approaches 0. So now we can take this limit x tends to 0 for all the terms in this compound inequality. Okay, now first let me take the limit for the stuff we have over here. That is limit x tends to 0, 1 negative x square over 2 less than or equal to limit x tends to 0 sin x over x less than or equal to limit x tends to 0, 1. Okay, now let's evaluate this limit. That is, we have to plug in x equals to 0. By direct substitution, we have to plug in x equals to 0 into the stuff we have over here. Then we get 1 negative. When I plug in x equals to 0 over here, it will become 0 square. 0 square is still 0. 0 divided by 2 is still 0. So less than or equal to limit x tends to 0. We can keep the stuff we have in the middle as it is because we have to evaluate this one. Okay, let's keep this one as it is. Then limit x tends to 0 sin x over x. Okay, less than or equal to, see here we are taking limit for the constant one. So if there is variable x over here, we can plug in the limit 0 for x. That is, we can plug in this value 0 for x over here, but we don't find the variable over here. We just have a constant. So the evaluation of this limit is the same constant we have over here. It's just 1. And so when I simplify this 1 negative 0 is 1. So less than or equal to limit x tends to 0 sin x over x less than or equal to 1. Okay, now how do you have to evaluate the limit x tends to 0 sin x over x from this step? Okay, for that we have to consider the squeeze theorem. So what is squeeze theorem? Okay, let's see the squeeze theorem. Let me write the stuff over here. Okay, to understand the squeeze theorem, first we have to consider three functions. For example, let's say that h of x less than or equal to f of x less than or equal to g of x. I consider three functions in a compound inequality. Okay, now let me take some limit, say limit x tends to a for all the three functions in the compound inequality. That is limit x tends to a, h of x less than or equal to limit x tends to a, f of x less than or equal to limit x tends to a, g of x. Okay, now, so let's say that the value of limit x tends to a, h of x is capital L less than or equal to limit x tends to a, f of x less than or equal to, and also let's say the value of this limit, that is limit x tends to a, g of x, also capital L. Okay, look at here. So now the evaluation of the limit over here on the left side extreme, it's L, and the right side extreme also the evaluation of the limit is L. So we have limit x tends to a, f of x in between the two same values L. So whenever we have a limit of a function between the two same values in a compound inequality, and the evaluation of the limit in the limit of the function, the middle of the compound inequality is also the same L, that is limit x tends to a, f of x equals to L. So this is called squeeze theorem. So the same thing we can apply over here. So the evaluation of the limit in the middle of the compound inequality so is equal to 1. So because we have the limit of the function sin x over x between the two same values 1 and 1. So then we have limit x tends to 0 sin x over x equals to 1 according to squeeze theorem.